All right, here we're going to get some practice on phase shift. If you haven't already tried these problems, make sure you try them on your own before you watch how I do them. Let's get the basic sine points down, and we're pretty quick with that by now. X, sine of x, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the y's in that situation would be sine of 0 is 0, 1, 0, negative 1, 0. Nothing is happening to y here. There's a 1 for our amplitude. There's no vertical shift at the end. All that's happening is that everything is being moved to the right. Pi over 2 divided by 1. Remember, there's a 1 out there as well. So we're going to move pi over 2 to the right. That means we're going to take and we're going to add pi over 2 to all of our x coordinates. So the new chart will be looking like this. So this is going to just be pi over 2. When we add pi over 2 plus pi over 2, we just get 1 whole pi. And then we've got pi plus pi over 2. That is 3 pi over 2. You have to do some fraction addition in that situation, but we did it up above. So, well, we did it in the previous video, so check that one out if you need to. Then we've got 3 pi over 2 plus pi over 2. That leaves us 4 pi over 2, which is just 2 pi. And then lastly, when we add 2 pi and pi over 2, we get a common denominator. In the end, we end up with 5 pi over 2. And so we've got 0, 1, 0, negative 1, 0. And our graph will look like this. I like these graphs because then we can just create our own scale. We don't have to worry about fitting in anywhere. And we can just say, okay, we're going to start at, I'm just going to call that right there, our first point. I'm going to call that pi over 2. And then there's pi, 3 pi over 2, 2 pi, and 5 pi over 2. All right, and so this one will just be the 0 here, then 1, then 0, then negative 1, and 0 again. So here's our cycle of sine, one full period. Try that again. All right, and we're left with these 5 points. All right, next example. So this time we're starting with cosine. And so our cosine points will be 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And with cosine it goes 1, 0, negative 1, 0, 1. Alright, and then we can just go ahead and take care of the fact that we're going to triple everything, triple all of our y's. And then everything is going to move down 2. So this goes to 1, negative 2, negative 5, negative 2, and 1. So we've got all that taken care of. Now all we got to worry about is shifting it. So let's see, we got our function is, let's divide some space up there and make this over like that. So we'll go our final function, which is 3 times the cosine of x minus pi minus 2. And so our y's are set now. We don't have to mess with our y's anymore. But our x's will all move pi divided by the 1, which is the coefficient of x. And they're going to all then move to the right. Pi to the right. Okay, so pi to the right, so that means we're going to end up at pi. And this one is 3 pi over 2. We've done a similar phase shift up above, so that's why I'm not spending a lot of time doing that addition. But pi plus pi would be 2 pi. 3 pi over 2 plus pi is 5 pi over 2. And then 2 pi plus pi would be 3 pi. So everything was moved 3 pi, or so everything has moved 1 pi to the right. So let's go ahead and get those points on our graph. This time everything starts at pi. And you may be like, well, where is pi? Do I have to worry about counting all the way to pi? One thing that's kind of a cool tool with graphs is I can just put this little squiggly right there saying, who cares what happened to the left? I'm interested most in what happens starting at pi. That's pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Then we have our x values of, our y values of 1, then -2 and -5, -2 and 1 again. And here's our most beautiful cosine graph ever that has been graphed. And so our 5 coordinates are these 5 right here. Okay, last one. This last one is going to take a while. So hopefully you've already tried it, and we'll take care of this together. So what you may notice here is that we have everything. We have a amplitude change, we have a vertical shift, there's going to be a period change as well as a phase shift, and this time it's going to go to the left. That's why this says challenge. But I hope you're up for the challenge, at least a few of you, and we'll get started right away. Here's our coordinates for sine. Feeling good so far. Let's go ahead and take care of the y's. The y's are the easiest part to take care of. All of our y's are going to double because of that 2 out front. So there's a 2, there's a -2, and they're all going to move down 1. So take that down 1, we're at -1, and take that down 1, we're at 1. Down 1 would be at -1, down 1 will be at -3, and down 1 we will be at -1. So here are our y coordinates, and these are our final y coordinates. That's all done now. When there is both a period change and a phase shift, we need to do the period change first. And so if you remember from the previous section, the period will equal 2 pi divided by the coefficient of x. So 2 pi divided by 2, which is pi. So our new period is just pi. And what that means is we're also supposed to divide all of our x's by pi so that we can figure out where they went and make sure that we have a period of pi ourselves. So I'm going to ignore that plus pi at the end right now, and we'll deal with that when we're all done. So our y's are set in stone, -1. Well, I'm not going to touch those right now either because I may need some more space than I've given myself. Let's try it out. So 0 pi divided by the 2 gives us still 0 pi, and it's got a y coordinate of -1. Then we've got pi over 2 divided by 2 over 1, and that becomes pi over 4. All right, and so that's got the x coordinate of the y coordinate of 1. Then we've got just pi divided by 2, and so our x becomes pi over 2, and that's got a y of -1. We've got be a lot of work on this one, but we'll feel better because we did it. Now we've got 3 pi over 2 divided by 2. That ends up equaling 3 pi over 4 with the fraction division. Hopefully you're able to continue doing that well. And then lastly, we're going to take 2 pi, divide it by 2, and we get pi. And so these x's over on the left side are what give us our period of pi, because we started at 0 pi and went all the way through to pi. Now, we're not done because we also have to take into account the fact that there's going to be a phase shift. And this time, if you remember, each time I've been saying the phase shift is whatever's being added or subtracted to x divided by the coefficient of x. So this phase shift is not just pi, and that's what's going to catch a lot of people here. The phase shift is not just pi, it's pi divided by the coefficient of x, which is 2. And actually, because it was a plus inside, it's going to go pi over 2 to the left. So we're going to need to take all of our x coordinates and subtract pi over 2 from them. So are you ready for this? That's why you're on the challenge problem. Here we go. Okay. So now that we're moving everything pi over 2 to the left, we got to subtract pi over 2. So that's going to leave us with a negative pi over 2 to start with. So actually we're starting on the negative side over here. Pi over 4 minus pi over 2. We need to get a common denominator. So I'll make this 2 pi over 4. So we're at negative pi over 4. And then this one, when we do pi over 2 minus pi over 2, that gets us back to 0 finally. 3 pi over 4 minus pi over 2, we'll again get a common denominator of 2 over 4. And so we're at 1 pi over 4. And then pi minus pi over 2 is going to just be pi over 2. And so these are our final coordinates here. Took a while, but we got there. These are our final coordinates. And so let's get that graphed and go to bed. Well, that's what I'm going to do. You might be in the middle of class, so I would suggest not going to bed. Oh, I can't do that. I can't do the graph I was about to do. I need to center it a little bit more because we're going to go to the left and to the right here. It's going to go all the way down to negative 3, so I'm going to have it look more like this. Here's my positive 1. Here's negative pi over 2, negative pi over 4, positive pi over 4, and positive pi over 2. And so negative pi over 2 is at negative 1. Negative pi over 4 is at positive 1. 0, we're at negative 1 again. Pi over 4, we're at negative 3. And pi over 2, we're at negative 1. Here is the most amazing sine graph you're ever going to see in your whole life. And the points are already written to the right, so I'm not going to write them again. Good night.